Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host, Shafu, and today's episode is with Hugo, who's going to walk us through Peanut Protocol. Hugo, thanks for taking the time, man.
Awesome.
Yeah.
Cool. So I'll start then. Awesome. All right. Well, thanks for inviting me. I think the way I'll structure this is I'll briefly do a little demo of what exactly Peanut is, in case people haven't heard about it, and then I'll explain the contracts to give some context. Um, so basically, the idea behind Peanut was it's quite painful. I don't know if how many times you've heard like, "Hey, what's your address?" or "Hey, like which chain do I send this on?" Quite annoying, and I think it's one of the many UX issues we have in crypto, and so we're tackling that. We're trying to make transferring tokens easier, and there's some neat use cases that spring out of here. So essentially, what can you do with Peanut? Well, you can send tokens with a link. That's the big idea. I'll do demo. Let's say I want to pay you $1 for inviting me to this awesome podcast. So what I'll do here is I'll just sign this if it loads. And yeah, this is just going to make a deposit on chain on the Peanut Vault. And there we go. I have my link. Now I can just copy this and put it in Telegram or in whatever I want. And the way that looks like for you is, let me just simulate this really quickly. I'll just open this and then there you go. I got sent $1 in USDC, and then I'm clicking on claim, and this will get executed, and I will have my funds. So that's it. That's the main idea, and we support like NFTs and also sending multiple things in one link. So if you want to send like a welcome pack to your friends, you can do it too. And yeah, one big thing that we focus on, and we'll see it now when we go through the contracts, is UX is quite important to us. And what that means specifically, for example, now you saw when I clicked on claim, I didn't actually have to sign anything. So this was a gasless claiming. So a transaction on chain still happened. So I still received my funds, but I didn't have to pay any gas for it. For the sending right now, I did. But we have a function for tokens to support this to also make that fully gasless, even if you're not smart like a kind of abstraction wallet. So that's something that's important to us. Cool. So I'll briefly just go through the link format and then let's hop into the contracts. So the way a link looks, it's just some parameters here. This denotes, in this case, this is Arbitrum. This is just the contract version. This is the deposit index. I'm not sure if you can see it on the shared screen.
Yeah, it's big enough,
But
I
yeah,
think.
and then finally, important here is, cool. Final important here is the password parameter. This is not sent to the server, so this is you can see this hash here, which Chrome and other browsers don't send that to the server. So this is a password. Essentially, it's like the seed to a private key, which we'll then see in the contract guards the deposit. Cool. So that's the main experience. Let's go into the contracts.
Nice.
Yeah. So we've had various versions of this. I think we actually started at ETH Berlin about a year and almost a half ago. That's when we did like an initial version of this. It was called, what was it? Cyber Scroll, we called that. I think the domain might still be alive. But yeah, unfortunately, we forgot to present to the judges, so we got disqualified. We slept over it. We thought it was just for winners' pitches, but yeah, a company came out of that, so that's cool. All right, so let's go through it. So this is a contract. Of course, we have some cute little ASCII here. Very important for all the cool contracts. Yeah, so we have a bunch of imports. Also just interfaces. We use EAP 3009. That's for the gasless depositing. So one big UX problem you have when you try to send funds, for example, when you go to Uniswap and you want to like swap some tokens, you have to do sign two transaction approval and then the actual transaction that you do, and that's super sucks. It's super annoying. So some tokens support EAP 309, which is transfer with authorization. Which makes it so you only have to sign one piece of data, and then that can get executed in one go. So you don't have to do this annoying approve and transact thing. Cool. So what exactly is the link I showed earlier? It's essentially just a deposit on chain. So this is the main data that is in each link. This is just a single deposit. Obviously, you can have links with multiple deposits, but the stuff here is this is the pub key 20. So this is the private key, or well, this is the public key. Without knowing that the private key corresponding to this public key, you won't be able to withdraw the funds in the link. That's what makes the link secure, essentially. So this password parameter that we saw earlier, this is the seed that gets from this seed we generate the public private key pair. And the reason it's a seed and not like a full on private key is just for shortness. Like we don't want these links to be too long. The shorter we can get them, the better. So maybe we buy p.to one day or something. Cool. So that's that. Then obviously there's other stuff has like an amount. Then we have like the token address, the contract type. Since we support Ether and ES20s and 721s and 1155 tokens, we need to handle them slightly differently. So that's why we have a variable for this. And with the claim and timestamp and token ID for 721s and address. We packed these variables just to be slightly more gas efficient. And yeah, so this is just the deposit struct.
Yeah, Hugo, I have one question. One question
Yeah.
regarding the versions. When you sent me the link to the repo like a couple of days ago, there still was V5. I took a look at the repo and you archived that like 2 days ago. So V4 is the current latest version.
Yes, so we had a slightly internal naming issue, but yes, the V5 that you might have looked at was actually deprecated. The V4.2 is actually the latest
Okay.
contract.
Okay.
And in fact, we decided to split up. So instead of having all the functionality in one contract, we decided to change it up into a peanut in a vault contract and then a router contract. So that was mostly, so then we could keep the V4 mostly the same, whilst having like specifically the new functionality was mostly cross-chain stuff. So the problem that solves is it's super annoying to have to like bridge funds every time and then send them to my friend. So now what we can do is actually have links that just natively bridge to something else. And in this case, we separate that out into a peanut router contract logic. Yeah, so I'll go briefly a little more through the Peanut Vault, and then I'll present the router contract. So the Peanut Vault, we have a deposit, and there's a few other variables here that deal mostly with signatures and making sure that well, we don't get hacked, because there's various ways in which you can compromise this or potentially. One general learning I've had is it's surprising how many bugs or ways of attacking a simple 500 line smart contract there can be. But I think that's just general for everyone, the right smart contracts.
Yeah, just imagine
Sure.
you
So
have more than
some
500
events,
lines, right? Just imagine you have more than 500 lines.
yes, one.
Yeah.
And the other thing, I think another thing that makes me sleep way better at night is that we don't hold a lot of TVL, because like Peanut is just for transferring funds essentially. So I create a link, then the funds are in the contract, and then you claim it, and then they're not in the contract anymore. So we don't hold that much TVL. So
That's good.
If we ever get hacked, it's not that bad.
Yeah, at Diet
pay that out.
we're nearly reaching $1 million TVL, and I start to get nervous a little bit. The contracts are simple too. Like I don't think we're over 1K lines of code, but yeah, it gets scary when you have the TVL.
Yeah,
That's true.
it makes you a little paranoid.
Yeah.
Cool. So yeah, very simple constructor. Here we have two hash functions, also like more utility stuff. I think the interesting stuff comes here. So when we make a deposit, we have two functions here, but these are just wrappers for the actual function, which is make deposit. We try to document everything, but not everything in the contract is documented. So I think we have to pick up on that a little bit. Yeah. So what happens in make deposit? So we have some information, some entry parameters here. Essentially, what type of token you wanna deposit, the token ID if it's a 721, the key you're guarding the deposit with, and the amount basically. And so yeah, so we handle these deposit types differently. So for ETH, we don't have to do much. For yeah, for ERC20, we moved into the contract. Same thing for ERC721, 1155. And then finally, we just guard save this and we populate the deposits index at the array. One important thing here is inflationary tokens are, sorry for this preview, slightly annoying. Inflationary tokens are not ideal for this model, because essentially you're making a deposit with a set amount of tokens, and if now the token rebases, this, like, we don't update the number in the Peanut Vault contract, but the Peanut now Vault contract has like less or more tokens depending on the rebase. So for rebasing tokens, you actually have to use a share-based model, which we don't have implemented right now. So there's one token that we use, which is Eco. That's rebasing, so we have an exception for them here. But for other rebasing tokens, it's not implemented. So that's probably for the future. But since I haven't seen many rebasing tokens for now, this is yeah. Just be careful about that. Cool. Yeah. So making a deposit, quite simple. You just send funds to the contract, and then a deposit gets made. Make deposit with authorization is almost the same thing, but as said before, this uses EIP 3009 to be able to make the deposit. The nice thing about that is now you can just sign something, or your wallet can sign something, and then you can send it to a relayer, and a relayer can create the transaction for you. So you don't actually have to pay any gas, which is nice. And we don't need user ops for that. Cool. Then we have a few other functions, which these don't get used that much. So we have functions in case you send an NFT to the Peanut contract directly. You can add some call data here, and if it's the correct call data, then that will also make a deposit. Else, if that's not the case, then it just rejects that, because we don't want people to send NFTs to the contract and then them being locked there. But these don't get used that much. And then withdraw deposit, I think that's a little more interesting than here. In withdraw deposit, this wraps the actual withdraw deposit function. The reason we have that is because there's two different methods to withdraw. One is directly, and the other one is withdraw through recipient, which is if you're withdrawing from a smart contract, in this case, the Peanut router. That's useful for avoiding front running. And yeah, in withdraw deposit, we have various checks. Essentially, well, these are relatively simple. And the most critical one is we check that whoever is actually asking to withdraw this has signed the payload with the private key. This is the private key that we talked about before. So the private key derived from this link parameter. If you don't have that, you can't do the signature. Therefore, you won't be able to withdraw the funds from the deposit. So I think one thing people get quite confused by often is this is not an account. So even though it's the same, elliptic curve pair that a normal account is and uses easy recovery, this is not like your account. This is like a pseudo wallet that we generate on the front end. So you don't actually have to sign anything. Instead, when I clicked on claim here, it just ran some JavaScript and it loaded that from here, and then it created a signature and it sent that to the server. The server cannot front end this because the signature, like the key is only known on the front end. And UX wise, you didn't have to actually sign anything with your wallet because this is not your wallet. It's like the link wallet, so to speak. Yeah. By the way, Shafo, if you have any questions in the meantime, please interrupt me at any moment.
I will.
Cool. Cool. Awesome. So yeah, so we checked that the signature is correct. And if that is correct, Then we met the withdraw event. We set also always do this. What's the pattern called in Solidity?
Yeah. What is it called?
Yeah, I forgot the name, but always follow the pattern if you don't want to get um, a reentrancy attacked. Cool. So we set the deposit claim thing to true. We used to actually delete the deposit, but now we just have a new status bool which sets it to true. And the reason for that is just to have on-chain, like we keep the on-chain data just for historical purposes, and then we can just read from on-chain and get like, hey, this deposit, even though it's claimed, used to have these values. So it's mostly quality of life thing. Yeah, and then we actually send over the funds to the recipient. One important, interesting thing here is line 538. We used to use .transfer here, and we used to have this. So in a I think it was V2 or V3 of this back when we were quite new. We used to have this at the very end, and here we had .transfer. And this would have opened up for an reentrancy attack. Fortunately, the .transfer keyword only allows, I think, 2,300 gas in Solidity or something like that. So it's actually not enough to do any reentrancy attack. But in principle, it could have.
Yeah, and the pattern is called checks effects pattern. Checks effects.
Yeah. Oh, if you're writing Solidity contacts, definitely follow that. I also try to use safe transfer and this other stuff, even if it's slightly more gas inefficient. Yeah, cool. So here we just move the funds out, and finally we just return that the function worked nicely. Yeah, so that's that. Then we have another. So one thing that also was new, I think, in V3 was, if you lose a link, that kind of sucks because now the funds are locked. Now we have a function called withdraw deposit sender, which means whoever created the link can actually, even if they don't know, even if they lost the link, and we do have a dashboard, and mostly we integrate with other wallets, and mostly they save this in local storage or whatever. But even if you lost it, that's not a problem because you can just withdraw as a sender, and this does not check. This just checks that the sender address in the deposit is whoever is calling this. And we can do this gaslessly too. So in everything, we try to allow both the gasless and the actual transaction call. Yeah, so this makes it so you don't actually lose the funds in a deposit, and then the rest of the logic is the same. More interesting stuff. Here's the gasless equivalent of this. Here we use verified gasless reclaim, and gasless reclaim we check that the signature that we get actually is a valid signature. So. And here's the hash of the reclaim functionality. So everything right now, like depositing, withdrawing as sender, depositing, all of these things can be done gaslessly, which I think is pretty cool. And I haven't seen it in many other contracts. And I really wish stuff like AP309 gets way more adoption. Cool. More than this, finally here at the very end, we just have some utility functions. In fact, many of these are not required. So get deposits and get all deposits. You can just call deposits directly, but we did this for quality of life. Just because it was the same JavaScript code in the SDK. And then finally, get all deposits for address. Also, just a read function. We offer an SDK to pair with this, just so you don't have to implement all this code yourself. And yeah. So yeah, this is the vault contract, relatively simple. It just makes deposits and allows you to withdraw those deposits. But the cool thing is this enables to make link payments. I'll go to the peanut router contract, which I think is also quite interesting. So right now in the vault contract, you'll see there's no fees and there's no upgradability. So both of things are, there's zero fees in that. I think the way we think about fees is more of a, hey, if you want to use the protocol and integrate with it on-chain directly, that's super cool. Just do that. Doesn't really make a lot of sense for us to do fees, because even if we did, people would just fork it, so it doesn't really makes sense. And instead, what we do is like, hey, we'll help you with like kind of like how like open core companies do it, like Red Hat. Like we offer this, and then we have the relay that you can call, and you can call gaslessly, and then make sure you actually really nice because like, hey, we do all this for you. Like we call it, and we make deposits for you. But maybe we take a small fee. Right now we take 0 fee. We might in the future, but for now we don't take a fee. But I think that's the revenue model. I think it's way more sustainable going forward. I'm frankly slightly skeptical. I think Uniswap can do it, but some of the other protocols that have like a, hey, we'll switch on a fee at some point, I'm slightly skeptical that it will work for many of them. I think that's just like a false promise. Yeah, but that's, I guess, adjacent to Solidity. Cool. So the peanut router contract, relatively simple. So this the main logic we have here is we have an optional fee mechanism here, which we can take. So essentially, the way that works is when you wanna when you're calling the relayer to like, hey, I want to withdraw this deposit to this address, you have to sign something on the front end, and that includes a little like parameter with the fee. So in this case, we're also using the peanut router to bridge funds. The way it works, we don't implement the bridge ourselves. We're using Squid. Squid is a pretty cool. Also, they also have like a. I don't know if you like our visuals. Here we have Squid, which also has like quite funky visuals, which is actually is one of the reasons we initially made friends with them. But they're really cool protocol, and they allow really quick bridging. And they have it's not intense, but they have like a well, I can actually showcase this really quickly. But yeah, the way this works is if I want to withdraw a deposit, like a $5 deposit on Polygon, even though it's an Arbitrum, the way that works is it goes from the Peanut Vault to the Peanut Router, and from Peanut Router it calls Squid. Squid sends it over to Axelar, and instead of having to wait 20 minutes for Axelar to actually bridge that all over, Squid they actually have like a pool on both those chains, and then they fulfill your order on the destination chain whilst they wait and take the risk on the bridging. In end effect, what that means is you can bridge funds in less than 20 seconds, which is really cool. Yeah, and personally, I think like with all the L2s and it's been a complete nightmare for me. Like such a waste of time to actually have to bridge over to I don't know, always get funds to deploy an exchange or try out or something. It's been super annoying. So I've actually been dog feeding Peanut a lot just to make that easier. Yeah. And yeah, this is relatively similar too. So here we verify a few more things. Also, again with the Peanut key. So we get the Peanut key from the Peanut contract, initialize that, we get the deposit, and then here we have it, and then we check that the routing signature is made by whomever made the deposit. So here's the puppy 20, and we check that the signature is done properly. That verifies that it's actually you who's calling, who wants to bridge these funds and not someone else. And yeah. And that's basically it. We also have a batcher contract. I think that's relatively simple. We just use a batcher contract to batch make a lot of deposits. So if you want to make a lot of ERC20 deposits at one time because you're a company and you want to make 1,000 Peanut links, you can use this. It's more efficient. So gas wise, it's cheaper because and also because you only have to update ERC20 balances twice instead of 1,000 times. So it's that's the main, I think, gas saving. And that's basically it. I think if you don't have any questions, Shuffle, I think a few more idiosyncrasies I think that might be interesting to talk about. We try to be deployed on most EVMs. One little bit annoying one was ZK Sync because they have a different Solidity compiler. So we have the ZK Sync thing. We actually had to use. So we have a folder here, so we use Foundry for everything, but we have a folder here called ZK Sync, which is quite annoying. because this is like a hard hat repo just to deploy to zk Sync network because zk Sync uses a different compiler. Also, zk Sync, another idiosyncrasy, the dot transfer keyword doesn't work, but since we moved to call data, then that's fine. Apart from that,
Okay, maybe one
yeah.
interesting thing about the ZK Sync, who we actually had
Yes.
Owen on, which is a good friend of mine. I think it was like the third episode, and he wrote this ZK Sync deployer for Foundry. So maybe you can take a look at
Ooh,
that. So you don't need hard hat actually. No.
I actually would love that. That would make
Yeah, we'll send it to
my
you. We'll
day.
send it to you after this.
Well, you learn something new every day. That's amazing. Um, cool. Well, I guess that's most of the contract thing. I think there's a lot of interesting stuff in the SDK too, but I think that's out of the scope for this. Yeah. Any questions? Anything you wanted to dig deeper on, Shaf?
Yeah, maybe what are the security assumptions for this?
Good question. So security assumptions. I think the key one is don't lose the link. So
Okay.
don't expose this link. So all this part is fine. But this part here that should be private. So that's an important one. Another secure assumption is that the key generation is random enough. So that was another vulnerability we had initially, which was the key generation for this, like the entropy being high enough. So browsers are pretty good at supporting that like secure random number generation for that right now. And this is, I think, 62 characters, so alphabet, lowercase, uppercase, and numbers, and 16 digits. So now should be more than enough to be secure, but you can make that longer too if you want. That's one. Apart from that, in the contract itself, there isn't many more. I think there's I mean, potential attack vectors are that, hey, in the Vault contract, this actually does hold a little bit of TVL. But and as we talked about, inflationary, so rebasing tokens are, so assumption is you don't use rebasing tokens. But apart from that, nothing else major.
Okay. Okay. So basically, whoever has the link can claim. And
Yes.
don't lose the link. Don't lose the link. Okay.
Well, losing the link is not a problem anymore because now you can just like withdraw as a sender, so you can always recover your funds. It's mostly like
Uh,
it's more like, I don't know, if you ever use in Web 2 like these magic link login thingies, right? Or like, hey,
mm,
like, which personally I find those websites kind of annoying because I like having my password manager, but many of them, many of the newer ones use like logging with magic link. So this has basically the same
yeah.
security assumptions as that.
Especially the Ethereum stuff, right? Like
Yes, yes,
East Global and yeah, they all use the magic link. Yeah, it's a bit annoying, that's true.
it is. But
Um, yeah.
one addendum there, Shafu, which I think is interesting. I think you can do. So I mean, obviously, there's a lot to be done with links, and I think it's super cool. But one thing you can do, for example, thing we thought about is you can have more secure transfers with links. So right now we only check for one thing, which, hey, do you know the private key? But you can check for multiple things. For example, I can send you a link that only Shafu, like your Twitter account, can claim. So you can, for example, do some OAuth verification on chain
Hmm.
uh, and check for a Twitter account. So then you could essentially, I don't know, if you ever like done like a big transfer of funds, like if you ever sent like, I don't know, like 10,000 or whatever, it's kind of dicey, but
Hmm.
and you always have to double check, especially if it's larger amounts. But if you have a link like this that has like multiple factors, then you can be a little more chill about it.
Interesting. Interesting. What are you other use cases do you guys have thought about?
Yeah, so I mean, obviously a big one and how we started is mostly with sending funds, so making all the payment life easier. Um, that's a big one, and that means, not having to think about like what address my friend has that I'm sending funds to, what chain he uses, what token he uses. Yeah, I think, sometimes people send me like shitcoins as a payment, and that's kind of annoying. So, So now I could just claim them as UCC, for example. So that's one. I think a big one we've also seen is welcome packs. So obviously we still need to onboard a lot of people to crypto. Cool thing about links is you can have multi links. So in this case this is just like one deposit, but you can have multiple deposits here, and then I can get a link with, I don't know, an NFT like an ENS name, some USDC, some gas, some stuff like that. That's we've seen a lot of that. Apart from that, I'm personally I find the more like security side of things, like links with like a lot of security gates, find it interesting for larger transfers. I find that interesting. Um, and yeah, in general, I think links can also be useful not just for token transfers, but for more arbitrary transactions. So one example could be, hey, you have an NFT I like. Here's a link that has an offer for purchase, or yeah, more generally, like you can. I think you can do a lot of with links, and they're nice because they're uh, um, well, you can always open them no matter where you are because everyone has browsers. Yeah.
Mm. What about some airdrop thing where you can, I think I read that in your docs, which I found interesting as an idea. Like distribute, your token through a bunch of links.
Yes. Yes. Yeah. We've seen. I mean, that's. I think that's particularly useful when you have a Web2 audience. So let's say you have an
Mm,
emails list, or like you know the emails of people or like their Twitter accounts or something, but you don't know their addresses or what address they want something on. So what you do is you just send them. I don't know. You can generate 1,000 links and then just send them in your newsletter.
yeah, yeah. Okay, maybe one last question, because I've never worked with gasless transactions. If you could
Yeah.
go into more detail how the gasless claim, for example, works.
Sure. Let's do that. I think that's a great question. So let's look at the withdrawal deposit function. So so here we have withdraw deposit, right? All this takes is the index of the deposit. So we have an array of deposits. In this case, let's say, well, let's just go to the example that we had before. So we had this deposit, this link. This has the index 54. Cool. So then this is going to be value 54. Address is going to be the address I want to send it to. So in this case, this was my address because I want to claim it to my address. Then we have extra data here, and which is not super relevant, and signature. The signature is essentially what gets checked. So here so this is the only data that we need, which means that anyone. So who can call this? Well, any account can call this, right? As long as these parameters are correct, it can be you that calls it with your EOA, or it can be someone else that calls this function. In this case, what just happens is that the signature is generated on the front end. So when I clicked on claim here earlier, what happens is there was a key pair that was generated from the seed. This key pair, the private key, created the signature, saying the signature essentially just says, "Hey, I want to receive the funds on my address." Right. So we created here a hash with like the peanut sol, the chain ID, the contract address, the index. These are just like for not being able to replay signatures. Finally, the recipient address, which is the key part, and we signed this, and this gets checked in the contract. Like here we check that, and what that means essentially is just like, hey, on the front end, you can create the signature, you can send it to the Peanut API, and our API can actually just submit that on chain for you, and then execute the function, and then the funds go to you, but you didn't have to initiate a transaction.
Mm, okay, okay. And in the back end, you guys pay the fee basically.
Exactly, yeah.
Okay, okay. Oh, that makes sense. That's yeah, no, UX wise, obviously, it's a pretty great feature.
Especially if you're, as you said before, like especially if you're sending this to like Web2 people through an email, they probably don't have a
Mm,
lot of gas, or like they don't have gas on this chain, or they're new users. So it's just a nightmare, and this way we can get around that.
yeah, yeah, yeah. No, that's true. That's really cool. Awesome, Hugo. Then, yeah, thanks. Thank you for taking the time. This was really interesting. I really like the protocol. Like it solves a very real problem. So that's great to see. If people want to reach out to you, I'm gonna put a link to the repository, a link to your Twitter. What's the best place to reach out to you guys?
I think so. Peanut Protocol Twitter, also my personal Twitter. Those are probably the best. We also have a Discord if you want to hop by and say hi. But what I really just invite people to do is, hey, if you're in crypto, um, just whenever you're sending stuff to your friends, instead of asking them for their wallet address, just send them a peanut link. And yeah, because it's surprising, because even I think it's just a change of behavior. It's surprising that even people I know still ask me sometimes for my address, and I just like tell them to use peanut. But yeah, very happy with this, and thanks for having me, Shafu. It's quite fun.
Yeah, of course, of course. Awesome, dude. All right, guys. Then I'm gonna put all the links in the description below, and I will see you in the next one. Hugo, thanks again. Take care,
Yeah,
guys.
bye.
Bye bye.